Hello and welcome. This is Bijan Hushiar. In this video, I'm going to demonstrate how to create a DHCP server to assign IP addresses to DHCP Client 1, Client 2, and Client 3. Then I'm going to add a rogue DHCP server to the network and see how it will disrupt IP addressing assignment to these three clients. Then I'm going to configure DHCP Snooping to prevent DHCP spoofing, which is adding a rogue DHCP server to your network. This internet network is created using 3 2960 Cisco switches and one 2911 Cisco router, 4 PCs and 2 servers. All the connections are straight through except between the 2 switches, which is crossover. I have already configured this router 1 with this IP address for G00 and this IP address and subnet mask for G01, and I've already configured PC2 with IP address of 192.168.2.2, a subnet mask of 255.255.255.0, and default gateway of 192.168.2.254. So the area that is designated with yellow eclipse is going to be used static IP addresses, and it has already been configured. The first thing is to configure a DHCP server. First, we need to assign an IP address to 192.168.1.253 with a subnet mask of 255.255.255.0 and default gateway of 192.168.1.254, which is the IP address of the G00 of router 1. As soon as we configure this server with the IP addressing scheme, if you go to the services and select DHCP for DHCP version 4, you'll notice a pool named server pool is created, and the IP address that is going to be assigned, starting IP address, is configured with that subnet mask, and 255 IP addresses are going to be assigned. The first thing that I do is turn the service on at the default gateway. I want the starting address to be 100, not 1. And I don't want 255 addresses to be assigned by DHCP server, only 50. I don't add it, I save it, because the pool already is created. If it's a new pool, you add it. Server is configured. Then I'm going to go to each client 1, and see if it can receive IP addressing from the DHCP server 192.168.1.100 with the correct default gateway. Second client, second available IP address in the range, the correct default gateway. And if I go to client 3, the third IP address available in the range with the correct subnet mask and correct default gateway is assigned. So that's how I configure the DHCP server with a valid range of IP addresses, possible optional parameters such as default gateway to be leased out to the clients. PC2 on the other side of the router is already configured with static IP address of 192.168.2.2 and default gateway of 192.168.254, which is the IP address of G0, one of the router. Let's see if there is end-to-end connectivity. Ping 192.168.2.2. 4 echoes are going to be sent and 4 echo replies are expected. It is possible for 1 or 2 or even 3 or all 4 of the echo replies are lost. You need to try it one more time. If for the second time you receive no reply, then there is an issue. There is no issue in here. All 4 replies are coming back. Now that's the first part. Now somebody has configured a rogue DHCP server with this IP address, that subnet mask, and that default gateway. It has also, that person also has configured a pool with this default gateway IPs to be listed out from this range, and it's going to connect it to the network. Let's go ahead and connect this rogue DHCP server to the network. I have to make sure that I see the bottom toolbar so I can access the cable. Here you go. Let me just go ahead and now we wait for the light to come up. As soon as light comes up, there are going to be 2 DHCP servers in our network. One of them is legitimate, one is not. Let's see clients are going to receive IP addressing from which one. We cannot tell which one of them is going to provide the IP addressing because DHCP version 4 is broadcast based. Let's go to client 3 and let's release and renew IP addressing. Let's do it one more time. It received from the rogue DHCP server. Let's go to client 1 and release and renew one more time. It receives from the rogue DHCP server. If we go to client 3 and do the same thing, it received from the rogue DHCP server. Is it possible for any of them to receive IP addressing from the legitimate one? Yes, of course. But there is no guarantee which one of them is going to provide the IP address. So this is called DHCP spoofing. A rogue DHCP server is added to our network. We want to make sure nobody is allowed to do that. In order to do that, we have to configure DHCP Snooping on both of these 2 switches. These 2 switches have no configuration. I want to switch SW1A, enable, conf T. I'm going to enable DHCP Snooping with this command IP DHCP Snooping. Then I'm going to make FA03 and FA04 trusted port as far as snooping is concerned, meaning to allow DHCP offer and DHCP acknowledgement to pass through them, because DHCP version 4 uses DHCP discover, DHCP offer, DHCP request, and DHCP acknowledgement. 2 of them are coming from the server. I want to allow those 2 to pass through these 2 helps, because this link is an extension of this link where our server is located. So I want to make FA03 and FA04 trusted. The other ports on switch W, SW on A untrusted. So interface range FA0324 IP DHCP Snooping Trust exit interface range FA01-2, FA0/5 through 24. IP DHCP should not be trusted. No IP DHCP snooping trust. So let's go ahead and do the same configuration on SW1B. On SW1B only we want to make FA01 trusted. First we have to enable DHCP snooping. Enable IP DHCP snooping. I'm enabling it generally. You can do it per VLAN by typing IP space DHCP space Snoopy space VLAN space the VLAN ID. Since all my ports are on VLAN bond, I don't bother with that command. Then I want to make just FA01 a trusted port. Interface FA01 IP DHCP snooping trust exit. The other ports on the switch I want to make untrusted. Interface range FA02-24. Since there are G 025 and 6 and 26 on the switch, you should also include them, but I'm ignoring them right now. I'm just working with fast Ethernet interfaces. These are the ports that are not going to be trusted. No IP DHCP snooping trust. The configuration is done. Let's go to the PCs. Client 3. It's received from the legitimate. Let's try it one more time. Received from the legitimate. Let's try it one more time. Received from the legitimate. Let's try it one more time. Received from the legitimate. Let's do client 1. Received from the legitimate DCs. From legitimate one. From the legitimate one. No matter how many times we try it, the rogue DHCP server is not going to be able to assign any IP address to these clients. That's how you configure DHCP snooping to guard your system against DHCP spoofing. Another good practice is to shut down all the ports that you do not need. For example, on SW1B, I only need FA01, FA02, and this one, FA03. The rest of them I really should shut down.
Thank you for watching. If you liked the video and you found it informative, please don't forget to recommend it to others who may be interested. Thank you.